Welcome to Module 7. In this module, we will look at how DC combiner boxes merge multiple PV streams safely, how string fuses prevent reverse current faults, and how to size the home run cable and the main fuse correctly. We will also cover real utility scale practice, including why large solar farms often use aluminum conductors for long DC runs. By the end of this module, you will understand how combiner boxes protect the array and ensure long-term reliability. A DC combiner box is where several PV streams meet. It reduces cable clutter, centralizes protection, and makes troubleshooting easier, especially in large arrays. It also provides a safe location for fuses, surge protection, and optional monitoring hardware. Each string enters through a fuse, connects to a busbar, and exits through a single pair of outboard cables. This layout ensures that if one string fails, the others keep operating safely. Combiner boxes are outdoor rated and designed to handle harsh conditions. PV string cables must be sunlight resistant and UV rated because they are exposed outdoors for decades. These cables are designed to handle high temperatures, constant sunlight, and long-term weathering. Proper polarity and labeling are essential for safe installation and maintenance. When streams are parallel, a fault in one stream can cause reverse current from the others. String fuses stop that reverse current instantly, isolating the fault and protecting the modules. This keeps the rest of the array operating safely. Fuses must handle the maximum current and voltage of your array, and rated fuses can fail prematurely, while overrated fuses may not protect at all. PV rated fuses are designed specifically for DC arc interruption, which is critical in solar systems. To size the home run cable, we start with the total short-circuit current of all strings, multiplied by 1.25 for continuous duty, and then choose a cable whose ampacity meters or exceeds that value. Copper requires a smaller cross section, but is expensive for long runs. Aluminum requires a large cross section, but dramatically reduces cost, which is why it's standard in utility-scale solar farms. The main fuse in the combiner protects the home run cable itself. Its rating is typically around 1.56 times the total short-circuit current of all streams. This fuse must be coordinated with the actual ampacity of the home run conductor, whether copper or aluminum. In large solar farms, the home run cable can be very long, sometimes over 100 meters. Copper becomes extremely expensive at those lengths, so aluminum is used to reduce BOS cost. Aluminum requires aluminum-rated luggers, oxide inhibitor, and correct torque to ensure long-term reliability. Such protection devices absorb transient voltages from lightning or grid disturbance. They are small components that prevent major damage and significantly improve system reliability. Good cable management improves safety and service ability. Neat routing, clear labeling, and consistent polarity make future maintenance much easier and reduce installation errors. Combiner boxes live outdoors, so sealing and torque checkers are critical. A loose terminal can cause heat buildup and long-term damage. Proper stream relief prevents cable movement and protects terminations. In summary, DC combiner boxes are essential for safe and reliable solar array operation. They combine streams, isolate faults, protect conductors, and simplify wiring. Proper cable sizing and surge protection ensure long-term performance, especially in large solar farms. In Module 8, we will move downstream to DC disconnects and isolation, the final step before the inverter. If you are enjoying this solar engineering series, feel free to like the video, subscribe to the channel, and share it with anyone learning solar engineering. Your support really helps me keep creating high-quality engineering content. Thanks for watching Module 7. I will see you in Module 8, DC connects and safety isolation.